Hi guys, this is Vishal. In my previous videos, I spoke about implementation of Kafka streams using DSL method. In this video, I'm going to talk about the second way of using Kafka streams, that is Processor API. I will divide this Processor API topic into two parts. First one, which means this video will cover building processor topology for stateless operations, and second will cover the stateful operations. As a part of stateless operations, I will take one scenario and try to build stream processing topology using processor APIs. Before we start with the actual implementation, let's quickly understand what is processor API and how it's different from DSL method. Processor API provides more flexibility to developers to define and connect custom processor to processing topology. Here, you can define arbitrary stream processor that process one record at a time. Processor APIs can be used to implement both stateless as well as stateful operations. For stateful operations, stream processors are connected with state stores. You can create a custom stream processor by implementing the processor interface, which provides the process method which is called on each of the received record. You can create a custom stream processor by implementing the processor interface, which provides the process method. This process method is called on each of the received record. So let's get started with the actual implementation. Here is the case. I have this processor topology flow diagram with me. At the top, we have a Kafka producer constantly publishing data on this loan detail topic. This loan detail topic keeps data related to loan processing accounts of various applicants along with their other informations like collateral and employment details in the form of Avro schema. Then later we have a very first node of our topology, which is source processor, whose job is to consume data published on loan detail topic. Further, we got two stream processor nodes, collateral processor and employment processor. These two stream processor extract collateral and employment related information from source topic, enrich the data by some means, and sync that enriched data again in the form of Avro schema into their respective Kafka topics using sync processors, that is sync 1 and sync 2. And finally, there is a consumer to print these two topic data consumed on console to verify stream processing is working as expected. I've already talked about producer and consumer in my previous video, so I'm not going to implement them here again. So I'll start directly from the source processor node. Alright, so let's get started. I have created this project called Spring Kafka Stream Processor API Stateless Operations, and I have already added few things here like consumer, producer, controller. Consumer and producer settings are exactly same like my previous video, so I'm not going to explain that. So in the consumer part, I'll just only say that I have added two consumers. One is to collateral enrichment data, which we are going to enrich, and the second one is for the employment enrichment. So these two consumers I have added just to print the data from the enriched topic to show that the stream operation, the stream enrichment operation is working as expected. Alright. And we have the producer to produce the data on the main source topic. So this one is the source topic, right? This loan detail Avro topic. So in order to push the data to this topic, so this Kafka producer I have created, and this REST controller which I was talking about is to push the data onto this loan detail topic, right? So on advance or on ad hoc basis, I will push the data on this loan detail topic. Now talking about this loan detail, I have used the same schema I was using in my previous tutorial, right? This loan detail schema. So I'm going to use the same one which has like applicant detail, employment detail, and like collateral detail and all these things, right? All the details we have here. So I'm going to use the exact schema in order to push the data onto the source topic. Then I have this application YAML file here, right? And here I have included producer properties like key serializer, deserializer. Then we have the schema registry URL, since we are talking with the Avro schema, right?
Then we have the consumer property similar to the producer, like group ID. Deserializer comes into the picture here, right? So key deserializer, value deserializer, and then again, since we're talking to Avro, we need to mention the schema registry. At the same time, I have also mentioned the two properties that we required for the streams, right? One is the bootstrap servers and one is for the application ID. And if I come down, I have mentioned the source and the sync topic names as well. The source topic is the primary topic, right? So loan detail Avro topic v1, and in the sync, the one which we are going to enrich the data and put it into the two different sync topics. One is a collateral and one is a employment, right? So these two topics I have mentioned. So these topic properties are my custom properties, right? So this is the application YAML for my project. All right. So here in the processor, I'm going to write first two processors. Like if you see into the picture, this collateral processor and the employment processor. Once we complete this processor, then we will write the topology builder. That's the main class which will drive our streaming operations. All right. So let's get started. So I will write the first processor here. So I'll create the class collateral enrich processor. Okay, let's annotate this class with @component or @service. Okay, I will extend this class with abstract processor coming from this org Apache Kafka Streams Processor. All right, it requires key and value, the key and value of our source topic. So key for the source topic is long and value is loan detail, right? Okay, once you extend this topic, you get to override one method. So I need to override this method called process. Okay, you got this. Long is the key and loan detail is the value. Okay, and within this process method, you have to write your enrichment logic. So my enrichment logic is, I'm going to extract collateral details out of this loan detail schema and add into collateral enriched detail topic. So this is the schema for my collateral enriched detail topic. So I will first create this topic here, right? Collateral new builder dot build. Okay, right? So now we need to set the values for this collateral enriched detail topic fields. So these are all the values. So I will just simply remove this one, and here instead of loan detail, so I will just simply use the same here as a value. All right. So I am setting this collateral ID, collateral description, collateral type, value, first name, middle name. So the first name, middle name, last name I took from the applicant detail along with the collateral details. That's how the enrichment works. So this is the normal, the very basic level of enrichment I am taking, right? Then approved amount, loan approval date, and loan ID. Now I will use this dot context. This context come from abstract processor, and here I am going to use method dot forward to forward the data, the enriched data, to the new topic, right? New topic means this collateral enriched detail topic. Okay, and for this we need to provide key and value. So for key to the new topic is collateral detail dot get loan ID. Okay, and value is collateral enriched schema. Right, this happens. Okay, this is how we are forwarding that details to the sync processor down. Okay, if you take a picture here, this collateral is forwarding the data to the sync processor here, right? Now we have forwarded. Now we need to commit the offset, right? So context dot commit, there is a method over here. Okay, once you add this, that means offset is committed once we forward the data. All right, so this is one processor called collateral enrich processor. Now similar to this, we will add employment enrich processor. Okay, so I will create one more class here name employment enrich processor, right? I will also annotate this class with @service, and similar to collateral, I need to extend abstract processor. Right now I'm using this deprecated. I'm sure there is one more class which is not deprecated present to write the processors, but at the moment I'm sticking with the abstract processor. Again here the key is long and value is loan detail because it's a source topic. This is the second processor which I am talking about, this employment processor which is again taking the data from the source topic. Okay, here I need to implement this process method, right? And here this is the key, this loan detail is the value, and here we need to write our enrichment logic. So first of all I am going to create this enrich detail Abro schema object, right? And employment detail, this new builder.build. all right, completed. Now employment enrich detail dot, we need to set all the properties, right? So employment type, okay, here employment type comes from loan detail dot get employment loan detail dot get it comes from okay, what is happening? Okay, employment details, okay, employment detail present under applicant detail. So I need to use get applicant detail dot get employment detail dot get employment type, right? So this way I need to take. So I'll just minimize this window, right? So second top field is employment detail is happened, completed, enhanced salary. Similarly, enhanced salary is also present in this employment detail coming from the applicant detail. So I will just copy here and dot get enhanced salary. All right, then employment detail enrich detail dot set enhanced salary is completed, employment type is completed, location, okay, dot get location, right? So and employment enrich detail dot set enhanced salary net salary. So this dot net salary, right? Then employment detail dot set organization name. So first I'm taking all the details from the employment detail, right? Then organization name, and then we have employment detail dot set position, right? So it's dot get employment dot position, and we have what else we have to take from the employment details? I think we have covered everything, right? Then first name comes from loan detail dot get applicant dot get first name, right? Employment enrichment detail dot set middle name, get loan detail dot get applicant detail dot get middle name, and finally dot set last name, right? Loan detail dot get applicant detail dot get last name. All right, this enrichment happens here, and now we need to forward again similar to collateral. So this dot context dot forward, right? And here again loan ID is the key. So loan ID comes from this loan detail dot get loan ID. All right, and employed enrichment detail enrich detail is my value, right? And finally list dot context dot commit. All right, so these two processors are ready now. Okay, we have completed the employment enrich processor as well as the collateral enriched processor. Now the next part is writing the topology builder. So I will create a package here called builder and within this package I will add a class Kafka Topology builder, right? Okay, I'll add this annotation @component, or let's say @service. Okay, the important object I need to auto-wire here in order to create the topology is the stream builder. Okay, so private stream builder, right? Stream builder, this is my object, and I will auto-wire it. Okay, then I would require Kafka properties in order to read the stream related Kafka properties. Kafka properties, right? Kafka properties, again I will auto-wire it. Then I need source and sink topics. Okay, so private topic, right, long and loan detail, right? The topic name you can pick up from here, right? We have configured this beans here, right? This loan detail topic. So I will copy and paste here, right? Similarly, I'll just copy the structure for two more, right? And one is collateral enrich and second is employment enrich, right? And I can take the bean names from here, the collateral enrich detail topic and employment enrich detail topic. Okay, and we need to auto-wire all of them. Auto-wire the loan detail, then auto-wire this collateral, similarly auto-wire this employment, right? Okay, we got everything we need. Now I will add a method public void build, right? And we need to, since we are talking with the stream, we need to add annotation @post construct, right? This will start as soon as our application start, all the beans are created, and then we'll start our streaming process. Now here within this build method, I'll write stream builder dot build. So it will return the topology object. So I will catch it in the topology object reference. Okay, now we got this topology object here. Now we need to add our actual processor topology. When I'm talking about the actual processor topology, means this, adding the source, adding this to processors, and then adding this to sink processors. All right, so let's add. So I will just minimize this window. Okay, so first topology dot add source. Okay, so source we need this. I'm going to take the name, two deserializers, one key and value, and then topic. Okay, so name of the source. Okay, so I will say source only, right? Then deserializers. Now here I'm adding the deserializers because this source is actually going to read the data from this loan detail Avro topic. It's not producing, it's reading the data. So in order to read the data from the topic, you need a deserializer and not the serializers. That is why this method is expecting you to give the deserializers. Okay, so you have this all deserializer details present under this topic object of this loan detail. Okay, so I'll simply say loan detail dot this value get key deserializer dot deserializer, right? Similarly, loan detail dot get value serializer deserializer dot, right, deserializer. And then finally we need to give topic name dot get topic name, right? So this source is completed. Now we need to add processors, right? So I will add processor. Okay, the processor, first processor, as you can see here, is the Collateral. Okay, so I'll give a name Collateral. Okay, and processor name is Collateral enriched processor, and it will initialize new object. All right, this is done. Then we'll add one more processor for employment, right? And here we need to add one more actually, who is the parent, right? Collateral has a parent named source, so that also we need to mention here. So my parent is source, right? Similarly, for employment, name is employment, then initialize employment processor object, and then parent is source, right? Now we need to add sync, right? Processors are completed. We need to add sync 1 and sync 2, this to sync processors. Now here I'll add first sync processor. Okay, name, I'll take this name, topic, serializer, I'll take this one. Okay, name, topic, key serializer, value serializer, and parent. Okay, so now a name is, I'll say Collateral sync. Okay, hyphen, right? Then what do you need? Topic, right? It requires what was required here. I'll go back once again. This one, topic, no. Name, this third one, right? Name, topic, serializer, key serializer, value serializer, and parent name. Okay, so first is a name. Okay, so name is Collateral sync, then topic, right? Topic names present in this Collateral enriched detailed topic name. So I will just say dot get topic name. Now serializers we need to write, because sync is going to write the data onto the topic. So here we need serializers. So Collateral detailed topic dot get key dot serialize, right? Similarly for value, Collateral dot get value dot serialize. And what's the parent for this? Parent for this Collateral sync is this processor. Okay, now as you can see here, for this sync one, parent is Collateral processor. So I will give this name, this Collateral is my processor name. So I will just mention here. Okay, similarly add sync for employment. So employment sync, then topic name, employment dot get topic name, then employment dot get key dot serializer. For value, same thing, right? Employment dot get value dot serializer, right? And parent is, who is the parent here? This employment processor. So this is my parent, right? Right, given. So my processor topology is ready. Now we need to start this topology. So in order to start this topology, we need to write this code, right? New Kafka streams. Within this I need to mention this topology and the Kafka build stream properties, right? So the stream config is required, and this Kafka streams is also required. So we need to add it into our class, and eventually I'll just need to start my streaming, right? So this my processor topology builder class is ready. Now let's try and run this application. Okay, so before running the application, I just need to correct one thing. Here in the application YAML, within the consumer, the key deserializer, I have given the string, but the serializer in the producer part, the key serializer is a long. So if I am producing a value in long, I cannot get into string, so it will have a class cast exception. So I need to have long deserializer itself. So here I will set to long. Alright, so this was the change I have done. Also in the consumer part, not in the consumer, in the processor, here I have changed the way we are creating the object of our schema, right? So earlier I was creating using collateral, using the builder part like this, collateral.new builder.build, but it will create a problem for me because I have not set any default values in my schema. So if I go to the schemas of this collateral, enrich or anyone, I haven't given the default values for any of the field. So when you create schema using this builder, it will create or it will throw an exception when application starts. So in order to avoid that, at the moment I'm just going with a new, right, initializing by myself. Similarly I have done for this employment enrich processor. Okay, so when you give the default values, you can use the builder way of creating an object. All right, done. So this was my change. Now I will start the application. You see, application is started as well as consumer is also started. So I will clear this logs, right? We have a REST service exposed, right? Loan detail data push controller through which we can push the data. So I have a Swagger enabled here. So this is the test schema object with the dummy data I have created. Okay, so I'll just update this loan ID to like say 9001. All right, okay, and some dummy parameter names I have given. So when I push this event to my source topic, at the same time the streaming will trigger and it will enrich the data for collateral and employment, and eventually my consumer will pick up and print onto the screen, so we can ensure that our streaming is working. Okay, so I'll click on this execute. Okay, this is successful. I got the message successful. That means this message is produced. So if I go on here, you see Avro message is successfully produced, and at the same time I got this message from the consumer saying employment enrich Avro message received. For the same again collateral enrich Avro message is received. Okay, key is loan ID as we said 9001, and here you see we must have received the data as expected, like first name, last name, right, middle name, and the way we have enriched for the employment, right, employment type, in-hand salary, location, net salary, organization name, position. And similarly for collateral, like I said, collateral description, this was the field in our enrich topic, collateral ID, collateral type, collateral value, then again first name, last name, right, approved amount, loan ID, loan account number, loan approval date, right, everything is we are getting from that topic. When so here we are able to enrich the data from the loan detail topic. Now I'll clear the logs and try to push one more field. Okay, this is going to be in a real-time basis, but I don't have a producer on real-time basis. That's why I'm adding the pushing the data on ad hoc basis. So I'll add the loan ID here to 9002. I'll change to State Bank of Maharashtra, right? Okay, I'll change the name here. Let's say test. Okay, middle name test middle, something which is to identify on the console, right? And let's say keep the day, last name, everything same, right? I'll execute again. Same message is produced. I'll come back. You see 9002 is a key, and here you see names have been changed. That means for the second event as well, the stream is been able to enrich the data for employment and collateral. So this way you can use a processor API to implement the Kafka streaming using your own customized processor topology for your business purposes. Thank you for watching.